Okay, so welcome back, and now what we're going to do is we're going to do a couple more examples. In the first one here, what they're asking us to do is to rewrite this or to find an identity for this expression that involves only sine. Okay, so that's what we're going to do. So the first thing I'm going to do is, and it's always good to just, when you're looking at things, see what you can do to simplify it or break it down. And in this case, since we're looking for sine, well, let's break things down and see what pops out. Okay, so the first thing I'm going to do is just simplify this and write this as 2 times. Now, cosine, I know I can write this as sine theta over cosine theta. And secant is 1 over cosine. Oops. Okay, and now what I'm going to do is, now I'm going to just combine things and write this as 2 sine theta over cosine squared theta, and then right there you should be thinking the Pythagorean identity, and you should know immediately what is going to happen. So again, this is going to end up being 2 sine theta, and of course this is going to be 1 minus sine squared theta, and we're done. So we found an identity for this that involves only sine, and that's what they asked us to do. Okay, now what about this one? Now here they want us to verify this identity using even, odd functions and algebra. Okay, so let's do some manipulations here. So again, let's simplify things. So again, what does the squared mean? So we've got a negative in here, negative in here. We know sine and cosine. Well, we know sine. Right? Sine is an odd function. Cosine is an even function. Okay? So let's use that. But before we use that, we've got this square in here. So we've got to rewrite this so that we understand that this whole thing is being squared. So let's do that. So I'm going to write equals, and I'm going to write this is sine of negative theta squared minus cosine of negative theta quantity squared all over. Now let's do the bottom, because the bottom we can simplify right away, right? And use the fact that that sine is an odd function and cosine is an even function. So we can write this as minus sine theta minus cosine theta. Or excuse me, yeah, minus cosine theta. Okay, so all I did was use the fact that sine is odd, which gives me this, and cosine is even, which gives me the same thing back out. Okay? So now I can use the even and odd inside here, and so let's rewrite that. So now I get the quantity negative sine theta squared minus cosine theta quantity squared. And I'm going to pull out the negative sign here. So this is going to be negative sine plus, sine theta cosine theta. Now I don't know if that negative is going to help me later on or not, but I saw it, so I pulled it out. Might not need it. Usually it's good, helpful to pull it out if you can. So now let's do the top here. Okay, so what happens on the top? Well, this here's I got a negative 1 here, right? Think of this as I'm multiplying by a negative 1, and I've got this exponent, so I can use the power property of exponents, and I get negative 1 squared times sine squared theta. So negative 1 squared is just 1. And so I end up with sine squared theta. And then this, again, just cosine squared theta, so we have minus cosine squared theta all over negative of sine theta plus cosine theta. Okay, so now, what can I do here? Well, what do I have on top? Notice that this is another common form that you should be familiar with. So think of this as x squared minus y squared. This is a difference of two squares, so we can factor that. And so what do we get? We get sine theta plus cosine theta times sine theta minus cosine theta all over negative sine theta plus cosine theta, and there we have it. Okay, notice I'm going to pull the negative sign out and pull it out front, because I can put the negatives on the top or the bottom, it doesn't matter. So I pull out the negative, this cancels with this, and I end up with a negative of sine theta minus cosine theta, but then the negative sign, if I distribute the negative sign, that will change the signs, and then I can flip it. So negative of this is equal to cosine theta minus sine theta, which is exactly what we got. So it's verified. So I just showed that this is equal to this. And that's it. Have a great day.